Okay, here's the Arduino website. Arduino.cc is the home page. I'm at the home page. I'm going to the learn right here. This says learning section. Going down to examples. I'm going to be carrying on with my projects. So far I've already done the blink, and now I'm going to do the next one in line. I'm going to try to do the digital read serial, which is basically it reads the switch and prints the state to the Arduino serial monitor. Hardware required is an Arduino board, a momentary switch like a button or a toggle switch, a 10,000 ohm resistor, a breadboard, some hookup wire, and here is the I'm going to come back and zoom in on this so you can see how to wire up the your breadboard and the resistor and the push buttons. Down here there's a schematic how this works, and here's your code. But if you go to the when you click on the Arduino icon after you download the software, all this code is already stored in that, so you can access it really easy. But I'm going to be building this circuit right here, so let me go ahead and zoom in. See, I'm going to make the screen bigger and the or try to. Hold on a second. Alright. Okay. Try to make that on the screen. Okay, that's about as good as I can make it. We got a breadboard here. This is 5 volts coming off of here, powering the breadboard. This is this ground coming up, powering the breadboard. Then your ground taps off of here, comes to a resistor, comes off the resistor, and the switch is this remains like if you read across here, this is normally closed, and so it always reads the input. So when the switch is off, this signal receives a ground signal or a low, and when you hold the button in, this comes up, sends a signal to the input. But I'm showing you this because this is how I'm going to wire up my stuff. Let me scroll down and show you the schematic. It'll make more sense on the schematic, I think. Let me zoom out a little bit. All this is on the Arduino website, and I recommend anybody check it out. It's all open source, and okay, here's a schematic. Like I said, this is this comes out a ground. Ground comes down, comes up. When the switch is open, this resistance isn't drawing any current or anything, so it just, this ground comes through and goes to the digital input. And when you activate the switch, you have your high voltage come down and go in. I don't know if that makes sense to you or not, or if I'm explaining it right, but when the switch is open, this input gets a ground signal, and when the switch is closed, this input gets a positive signal. And you'll see how that works when we monitor the serial port. Here's my breadboard. Here's my Arduino board. I'm going to get everything ready, and then I'm going to plug it in and then upload the code. I've got my momentary switch. I've got my 10,000 ohm resistor. And I've got all my jumper wires I need to hook up wires or jumper wires or whatever you want to call them. And you're going to need your USB cable that looks like a printer cable. USB on this side, and not like the same thing as what you hook into a printer. Okay, let me get busy. And I'm going to wire this thing up exactly like it said on the Arduino website. See if I can get it to work. Okay, on my Arduino board, I'm going to plug in the cable, the power cable, and this gets power from the USB port. I'm just going to set this aside for now. Okay, I'm trying to do a real close-up so you guys can see what I'm doing. I'm going to start off with my switch. I'm going to straddle this gap here. Just push the switch down. It's going over this gutter here. Okay. I've got a ground wire. I'm going to hook this into my negative bus bar. This just, if you hook in power or ground here, it powers this whole rail. So I'm going to hit my negative here. Got negative. I'm going to hook up my positive just right here. Okay. Now I'm going to take my ground and I'm going to hook it up to the ground. Let me show you. See here, there's a voltage in, and this one right next to it should be a ground. This is also a ground. Ground, ground. I'm going to use this one right here. Okay. Now I'm going to hook up also my power. I'm going to send it to this 5-volt pin, which is right here. Okay. So should have 5 volts in ground, and if you count them, 1, 2, 3, 4, 1, 2, 3, 4. Second's ground, fourth is 5 volts, should be in the right spot. Okay. Now my digital it's going to go to this pin up here. We got receive and transmit pins, and that's 1, 2. I'm going to go to pin 2. So I've got that going to pin 2. Now that's pretty much ready. Alright, on my breadboard, I want to be in line with any one of these. We'll connect this to the switch. I'm going to go there. Okay. Now my resistor has to be off the switch. So I'm just going to connect it here and here. Use a little pliers to push that. Alright, so got the digital input coming to here through the switch, resistor here. Now I need to hook up a jumper wire to ground. And I need to ground this resistor leg. Okay. Now I just need to hook up power from here to the button. Okay, let me go right here. I got my power. Power there. And I'm going to power this side of the switch here. That should, let me get this a little out of the way. Double check your circuit. Okay, I got 5 volts and ground coming in to power the rail. Got my ground going to my resistor, through my push switch to the digital input. And on the switch side, I got just power. Yeah, I should be wired up right. Click on the Arduino icon. Go to File, Examples, Basics, Digital Read, then maximize it. Now this is my code. This is all my code for to make this work. Pretty simple. Let me show you when I got my board all ready, getting ready to plug it in. Okay, when I plug it in, looks like it's powering, getting power here on the light came on. But anyway, let me show you real quick. I'm going to go up here, I'm going to verify my code. So it says verify. It's compiling. It's done. Now I go here to the upload button and I upload, and it says uploading. Done uploading. Okay, now if you notice, there's nothing going on here, nothing happened, but what this is for is to write a program to monitor the status, continually monitor the status of this button. And the way that works is I go here to I think it's under tools, and you go down to serial monitor. See that? Serial monitor. And if you notice, let me zoom in a little bit. Well, it's just constantly monitoring the state of that switch. Watch what happens when I want to push this switch down. I'm going to hold it in. When I hold it in, it should start reading ones, and it is. See how that's reading 1, off, on, off, on. I'm holding it in. Off, on, off, on. Okay, see, it's just running a loop, and all that's doing is just monitoring the status of this digital input, and it's doing it at this speed rate, this baud rate, 9,600. Same thing here. It's doing it at that rate. The way the circuit is set up, the reason why this has to be pulled to ground when the switch is open, so the computer can get a good signal. Because if, for instance, if this wasn't pulled to ground, the computer, the voltage would be jumping, floating, bouncing, ghosting, whatever you want to call it. And I'll show you that. Watch, I'll pull this out and watch what happens to our signal. I unplug that and look, it's erratic. I'm seeing ones and zeros and ones and zeros. The computer can't monitor that because it's bouncing. I mean, when you open up that circuit and don't have it going to ground, that input starts floating. You can see that the computer doesn't have any idea what's going on into that, because it's not a good signal. It's bouncing. Watch what happens when I plug it back in. Should go back. And it does. Goes back to 0, not bouncing anymore. Okay, now I'm going to show you something on a fluke meter that kind of demonstrates the point I was just making. Okay, got it set up on millivolts DC. Okay, now in most computers they got like a voltmeter or something just monitoring voltage inside the computer, and when if you don't have like a pull down resistor or a pull up resistor, just you have it open like a regular circuit, like you turn it off, it opens it up. Or let me show you what happens. Like right now you can see this represents like a circuit that would be open, and you can see this signal is just bouncing all over the place. And let me see how that, I mean, if I wiggle the wire a little bit, it'll even bounce even more. That represents like the voltage bouncing on a circuit. If you just open a switch and you don't set it up to be a pull down or pull up resistor, the computer will see that, and it'll be erratic, and the computer would have no idea what your state is, either it's high or low. But look what happens if I give it a negative signal. It pulls it low and it stays there. See, if I hold these leads together, that's what you want. See, if I wiggle the wires around, there's no bouncing around. So it's the same idea as to why you need a pull up or pull down resistor. It's so your computer doesn't get fooled by this, and it sees that jumping around like crazy. And as you saw when I pulled open that, when I opened the digital input, I created an open just like this, open, and it's jumping around, and you saw it read 0 1 0 1 0. It was doing crazy stuff. So I mean, this is the reason why you need a pull down resistor or a pull up resistor. Pull up would pull the voltage high and stay there. Pull down would pull it low and it'd stay there. Hope that makes sense. But anyway, at least that's how I understand it. I'm not an electrical engineer or anything, but that's the way I interpret it.